Exercise or fasting will trigger an increase in epinephrine in the bloodstream. Epinephrine will then stimulate the beta-adrenergic receptor in adipose tissue and increase the lipolysis of stored triacylglycerol. Epinephrine activates the beta-adrenergic receptor, which in turn causes the increase in cyclic AMP in adipose tissue, which in turn activates protein kinase A, which in turn phosphorylates hormone-sensitive lipase and activates it, resulting in the hydrolysis of triacylglycerol and the release of 3 fatty acids and glycerol to the bloodstream. In the well-fed state, insulin will promote the dephosphorylation of several enzymes by activating a phosphoprotein phosphatase. It is noteworthy that insulin binding to the receptor activates the intrinsic tyrosine kinase activity of the receptor, which autophosphorylates itself on specific tyrosine residues and phosphorylates other cellular proteins on tyrosine residues. Thus, the activation of the tyrosine kinase activity of the insulin receptor starts a cascade of intracellular events that lead to the activation of a phosphoprotein phosphatase that is specific for dephosphorylating proteins and enzymes on phosphoserine and phosphothreonine. One such enzyme that gets dephosphorylated by phosphoprotein phosphatase is hormone-sensitive lipase. The insulin-induced dephosphorylation of hormone-sensitive lipase inactivates it, and as a result, lipolysis of stored triacylglycerols in adipocytes is inhibited. If you like this video, please subscribe. Thank you. Chylomicrons are lipid particles assembled in the intestinal mucosa, and their composition reflects the composition of our dietary lipids. They're 85% triacylglycerol and about 15% of cholesterol esters and phospholipids. The apoprotein ApoB48 helps in the release of chylomicrons into the lymph and eventually the bloodstream. During their passage in the bloodstream, chylomicrons are acted upon by lipoprotein lipase associated with the endothelial wall, releasing 3 fatty acids which are picked up by neighboring tissue. Fatty acids released from triacylglycerols within the chylomicron are taken up by the surrounding tissues for either use of those fatty acids in metabolism or storage of those fatty acids in the form of triacylglycerol. The majority of dietary tags, excess dietary tags, are stored in adipose tissue. The third important feature of lipoprotein lipase is that it is induced or upregulated by insulin, meaning that the number of enzyme copies expressed in the endothelium is increased. Therefore, the total activity of the enzyme is increased, and this enables this enzyme to access circulating tags from the diet after a meal. The upregulation of lipoprotein lipase by insulin is quite important because any decrease in the activity of LPL could result in hypertriacylglycerolemia. This dyslipidemia is typically associated with insulin resistance. Insulin has profound effects on both lipases, lipoprotein lipase and hormone-sensitive lipase. Consequently, changes in the activity of these two lipases in response to insulin may contribute to the dyslipidemia associated with insulin resistance. In summary, the dyslipidemia associated with insulin resistance is due to 1. A decrease in the overall activity of lipoprotein lipase, resulting in accumulation of triacylglycerol in the plasma, and 2. An increase in hormone-sensitive lipase activity in adipose tissue, resulting in increased fatty acid release from stored tags in adipose tissue. Together, the changes in these two lipases contribute to the changes in plasma triacylglycerol and fatty acid content, and therefore contribute to the observed dyslipidemia associated with insulin resistance. If you like this video, please subscribe. Thank you.